Hello again. Previously, we have covered part of chapter 3, which include read-write, arithmetic and logic, and some other branching. And we also have some form of branching like bit test. And after this, we're going to continue with some other examples: counter, if else, subroutine, lookup table, timer, and delay. Right. Let's recap what we have learned so far. By trying these questions, there are three different questions, number 1, number 2, and number 3. So number 1 is simple one, the simplest one. Move 34H into W register. So it's simple as MOVLW into 0 times 34. Okay, as simple as that. Second question, add values 16H and CDH. Place the result in W register. For this one, you need to move literal to 16H or 0 times 16. Next, just add them up. Add LW 0 times CD. So that's basically it. Okay, and the results will be placed in register W. Number 3, write a program to toggle special function register of port B. I'll just strike this because I don't want to confuse you, because SFR is actually port B is actually part of SFR, okay, special function register. Okay, the program must be continuously repeated forever, right? So I'm going to skip some earlier part of program code, like bank select and all that. What I will do is straight move LW port 0 times 55, and then move WF port B. After that, by right we should have a delay. If you are using LED, then you need to have a delay. Okay. If not, then you can straight away use a move. Just for the sake of writing this program, we are not gonna test it on LED. So we just use straight away toggle it. So move LW 0 times. Okay, what is the right number for it? Okay, 55H is 0101 0101. So if you toggle it, 0 becomes 1, 1010 1010. So this one is 55H. This one is AH. Okay, if you are not sure, just double check. 100 is 8, 1001 is 9, 1010 is A. So that's the easiest way to memorize it, just in case if you forgot. So move LW 0 times AA, and then move WF port B. So right now we have at least toggle port B at least once. So we want to make, how do we make it continuous repeating program code? So you have to use go to and then loop. Okay, so the loop has to be here, okay, at the label part. So move LW55 port B, then move 0 times A port B, and then loop. It will loop again and again like forever. Okay, you have to use this as a reference, the instruction, list of instruction. So you have to follow the format. Okay, branch instruction is actually very useful for any microprocessor or microcontroller, as it actually changes the sequence of a program. basically when you microcontroller is a sequential machine, which means the program is executed one line after another in sequence. So that's what I call sequential. Okay, so every instruction is saved in one memory location. So the instruction is executed one at a time. And then the branch instruction instruct the machine to go a different memory, meaning if you can see there's a line of codes like this. Branch instruction basically it does number 1, number 2, number 3. Suddenly branch wants you to go somewhere else. Okay, probably line number 10 or whatever that you want to go. Okay, wherever you want to go. So that is the function of branch. Okay, so when it's execute the instruction, it will go to the new location. For PIC16F84, there are multiple codes related with branch instruction. For example, as you can see here, we have bit test file skip if clear, bit test file skip if set. Clear means what? 0. Set means 1. Okay, and then increment f skip if 0, decrement f skip if 0. Okay, these are all under check condition. Okay, so if the condition is met, it will skip the next instruction. And then there is another instruction, go to. Okay, go to means you you want to move to a specific instruction or code sequence. And then there is a call and return. This is basically used for subroutine. Subroutine is basically a function. Okay, if you're familiar with C programming, when you call a function, and it will go to that function, do a certain jobs, and then comes back to the original or to the last sequence that is being saved into stack. So that's basically the subroutine. And then RETLW. Okay, RETLW is actually lookup table or array. Later on we will have some example of this later on. Okay, besides branch, we also have counter, which means we create loop using assembly language. In our application, sometimes you want to repeat certain tasks many times. So that's why we need to use counter. All right. For example, of the application is input data into multiple memory location. For example, you have many memory location. You want to put data here, and then next one and the next one. So you have to use. You're actually doing this repetitively. So instead of writing the code one by one to do the same job, so better do some loop, which looks more smart. Okay, program looks more smart, and it saves a lot of memory location. Besides that, you can use it for blinking LED 400 times, for example. And then you can also use counter to continuously blink LED. Okay, for counter or loop. Okay, by using counter or loop, as I mentioned just now, we can reduce the number of instructions instead of you do everything one line after another. So besides of, let's say you have this up to 10 lines, okay, you might probably just need like 3 to 4 lines instead of 10, and then it will just like loop here again and again until the counter is finished, and then it will skip and do the next one. Okay, so it actually optimizes the memory space. As you know, PIC16F is a simple microcontroller, so it has some limited memory. In C language, it's very simple. So we structured syntax using for loop, while loop, or do while loop. Okay, for looping. But in assembly, it's a bit tricky. Okay, we only have a limited number of instructions. For example, go to bit test flag, skip if carry, skip if clear, bit test flag, bit test file, skip if set, increment f, skip if 0, decrement f, skip if 0. So you need to be more creative. You need to use all this, but you need to be more creative. You can't just have a simple instruction to do it all. Okay, it's not like C programming. Right, there are 3 steps in designing counters. All right, first you have to initialize the counter. Okay, and then load register with certain value to determine the count value. Okay, and then counter update, meaning you update the new value of counter, okay, by increment or decrement instruction. Remember, we have that increment f, skip with 0, and then decrement f, skip with 0. Okay, and then after that you have to do looping. You set up loop with condition. So what kind of condition? It's this thing just now. Okay, if this condition is met, it will skip. If not, it will, you just go to loop and go back. So this is the label, okay, which is located in label column, whereby the go to instruction will jump back to the loop, right? So basically the flowchart is like this. Initialize meaning you set your count number. Let's say you want to repeat 10 times. So the first one, you decrement, update the count, and then check. If not, repeat. Okay, and then update the count and check again. If not, repeat. If it's final count, yes, and then exit the loop. So that's basically the basic of counter and loop. Right. The structure, as I mentioned just now, it looks like this. Okay, you have loop, and then you have your instruction, and then go to loop, which means it go back here and then do the execute the instructions. So this, what it does here is an infinity loop, meaning it will do it forever. But if you want to have a fixed number of loop, for example 100 times, okay, so you have to make use of counter. This is just a counter EQU 0 times 40. Counter here is just any variable you want to use. So this variable, when you use the EQU here, okay, EQU is not an instruction, but it's for the assembler to translate as some sort of definition. So counter EQU 40 H, here it means we use the memory or the register available, and we name it as counter. So what we do here, move LW D100. D100 is decimal number. D100 is a decimal, meaning you want to loop 100 times. Okay, so and then move WF, meaning 100, you move it to counter. So you save it in the counter. So 0 times 40 is the address, and then the data is D100. Okay, in hexa, I don't know, you have to press the calculator and see what's the right number for hexa. Right, and then so the counter now have a number of 100, and then put a label loop here where it will indicate the program to come back here. And then after that, you add your task, add your program code, whatever you want to do, and then now here, decrement f, skip with 0. So decrement f meaning decrement the counter. So up to this point, just now it was 100, now it becomes 99. And then go to loop, go back here, and then do the task again, and then just now it was 99, decrement F another one, then it becomes 98, and then go back loop. Okay, 98, 97 until it becomes 0. What happens is it becomes 0. When the counter is 0, the instruction will skip. Okay, the instruction will test if the answer is 0. So if it's 0, it will skip the instruction, go to instruction, and then it will do the next instruction. Okay, it will not execute the go to instruction. That was the function of decrement F. Okay, this is another way to increase. You know, we have 8-bit memory. Okay, if its maximum number is 0 to 255. If you want counter more than that, you have to use at least 2 memories. Memory location. Okay, why? Because maximum for 8-bit memory, the maximum number will go only up to 255. Do you understand what I mean? You see, 0, 0, 0, 0, 0, 0, 0, 0. This is 8-bit, bit 0, and this is bit 7. See, so this is the first number. Okay, second number, 0, 0, 0, 1. Okay, so that is the second number. When everything is full, it becomes 1, 1, 1, 1, 1, 1, 1, 1, which means this is the last number, 256. Okay, the last number, the 256 number, right? So basically, when I mentioned 0 to 255, basically this number, the first number is actually 0. The second number is actually 1. So here is 255. Okay, so now that you understand that the memory is up to 255, so how do we use how do we work around if we were to have 1000 times counter? You want to count up to 1000 times, so you have to use at least 2 memory location. Look at this example. How do we work on that? Okay, count 1, count 2. As I said just now, this is the variable. Okay, this is the variable. You can use whatever names that you want, and then you use this EQU. Okay, meaning equal, and then this register address. Right, so use this register address, and then later on the assembler will translate it, okay, to 0 times 40 equals to count 1. If not, you can just actually use instead of count 1 here, you can use 0 times 40. But you know, when you do programming, you have to use something that is familiar to you, so that it's easier for you to troubleshoot. So instead of using the 0 times 40, you use count 1. Okay, it's just a name, like they use port B, port B, port A. Port B refers to one number. If I'm not mistaken, 0 times 85 or 86. You have to refer back to the memory allocation. So you just move LW port B, but actually you move LW to this address. Okay, that's what is actually happens. Okay, coming back to this. So count 1, count 2. The number here, you have to use the right number. How to know what is the right number to? I'm sorry. I'm not talking. It's not this. The right number. I'm referring to this. Okay. Because it shows the number of count that you need to use. So you put number D200 for count 1, and then D5 for count 2. And then you decrease count 1 up to 200 times, and then decrease count 2 once, and then reload count to 1 200 times again, and let it loops. It's actually is shown here. So this is the loop label, okay, and then do whatever you want to do here, your program codes, and then after you have done that, you do decrement F, skip if 0, count 1 1. So meaning number 200 just now, it becomes 199. Then go back to loop, and then again do your task, and then decrement, it becomes 998. Go back to loop, and then do again and again until this one becomes 0. So once it becomes 0, what will happen is you skip the go to instruction. Okay, you skip go to instruction, and then move LW D200, meaning you refresh the counter. You start from 0 again, and then move WF count 1. So here you refresh count 1. Remember, in the first loop here, the count 1 is already finished. Okay, it becomes 0. So what you do is you update the counter. Okay, start from 0. After that, decrement count 2 once, and then if it's not 0, go back. So meaning you have to do this all over again. You minus from 200 until 0, and then only after that you decrement count 2 once. So how many times you are doing the loop now? So basically you have count 1 is 200 times count 2 is 5. So you have 1000 loops. Okay, so that's basically how the counter loops is being used. Okay, this is an example of program, create loop using assembly. It's a lengthy process. I need you to study this, okay, understand what does this all this program do. Okay, later on you do it again without looking at this example. Okay, you do it one more time without looking at the example. That's how you learn how to write a program code. Okay, this program will be using indirect addressing. You can see FSR INDF here. So you need to study how to write the programs like this. And then another example where the loop will stop if it meets certain criteria. Okay, I'm not going to go through this for the time being, because after this we're going to go if-else structure.